Hey guys, welcome back. And in my last video, I was discussing about the preparation of haloalkane and haloarenes. And this class, I want to discuss the chemical properties of haloalkane and haloarenes. Basically, haloalkane shows nucleophilic substitution reaction. So in this video, I want to discuss the nucleophilic substitution reaction. So my name is Vivek, and you are watching BS Chemical. Let's begin. As you know that substitution reaction is the reaction where one of the atom attached to the hydrogen is replaced by another atom. If hydrogen is replaced by another atom like A, then the compound is CH3A. So here is called substitution reaction. So what is nucleophilic substitution reaction? That if a substitution reaction is initiated by a nucleophile, then it is called nucleophilic substitution reaction. If the substitution reaction is initiated by a nucleophile, is called nucleophilic substitution reaction. Right. So then first question is arise. What is nucleophile? Yes. Then nucleophile is a ion or a molecule which donate a pair of electron to the carbon and make a bond with the carbon. So nucleophile is a ion or a molecule which donate a pair of electron to the carbon atom and make a bond. Okay. So basically nucleophile is two types. One is negative nucleophile, another is neutral nucleophile. So basically it is two types. Negative nucleophile neutral nucleophile. Right. So first you should know what is negative nucleophile means. First is negative nucleophile. OH minus HS minus R O minus R COO minus etc. These are basically the negative nucleophile. Hydroxide ion HS minus and RO minus RCO minus. These are the basically negative nucleophile. And neutral nucleophile is NS3 H2O RNH2 R2NH and R3. These are the basically neutral nucleophile. The lone pair contained by nitrogen and oxygen in ammonia in this is amine in primary, secondary, and tertiary amine. The lone pair contain the nitrogen, so that lone pair can attack to the carbon. So it is act as a nucleophile. right? So then go to the nucleophilic substitution reaction, right? So as I previously told you that nucleophilic substitution reaction is initiated by the nucleophile. So basically nucleophilic substitution reaction are shown by alkyl halides. So the nucleophilic reaction is two types. Nucleophilic substitution reaction is two types. First, SN1 nucleophilic substitution unimolecular. Second is SN2, that is nucleophilic substitution bimolecular. First is nucleophilic substitution unimolecular, second is nucleophilic substitution bimolecular. Nucleophilic substitution divided into two types. So this video I will discuss the nucleophilic substitution bimolecular. SN. We all know that carbon and halogen bond is partially polar, so that this is partially positive and this is partially negative. So there is a probability a nucleophile can attack to the carbon atom, so that the bond is breakdown and nucleophile is leave. This is nucleophile and this is substrate. When nucleophile come to the carbon, then the halogen carbon bond is breakdown, so that the compound is formed like here X minus, this is called leaving group. This is called leaving group. What happened here? Nucleophile come, attack to the partially positive carbon atom, the carbon halogen bond is breakdown and the nucleophile halogen bond is nucleophile carbon bond is formed. So the product is this. So if we take an example, let us consider nucleophile like OH minus, and his substrate is HCl, methyl chloride. What product we will get? That nucleophile attack to the carbon, so carbon halogen bond is breakdown. So product is OH plus Cl minus. This is the basic reaction. This is the overall reaction, and if I go through the mechanism of the reaction, this is a single step reaction. Like nucleophile attack to the carbon mechanism. Here a transition state is formed, that is So, when nucleophile, please let understand the complete mechanism. When nucleophile attack to the carbon, which is partially positive, then there is a transition state is formed where the nucleophile partially bond with chlorine and the nucleophile partially bond with carbon and then carbon partially bond with chlorine. So this is the transition state. In transition state, carbon is pentavalent because here you can see that carbon make 5 bond. Here the nucleophile come attack to the carbon and chlorine is leave simultaneously, and this transition state is formed. Then product is formed like that. As you can see that the nucleophile come from the backside of the leaving group, and when the product is formed, that hydrogen which are present in the side of the attacking side of the nucleophile, they come back to the backside of the carbon because nucleophile is rich in electron. If they come through this way, then that hydrogen attached to the carbon is go this side. So the configuration is inverted. Is inverted configuration. Okay. These are the basically of a mechanism of the nucleophilic substitution by molecular reaction. First, the nucleophile attack to the carbon from the backside of the nucleophile, backside of the leaving group. Next step, the bond between carbon and nucleophile start making, whereas the bond between nucleophile, bond between carbon and the leaving group start breaking simultaneously. That means the nucleophilic and carbon bond start forming, and the carbon and leaving group start breaking simultaneously. That nucleophilic attack and leaving of the carbon, leaving of the leaving group is simultaneously. The product is inverted in configuration. The product is formed which is inverted in configuration. It is a single step reaction. In the reaction, a transition state is formed. The rate of reaction is depends upon the concentration of substrate and nucleophile. Rate substrate concentration and concentration of nucleophile. Okay. So actually the rate of the reaction, what is the rate the react and product is formed? This is the rate. So how means the rate of the reaction directly proportional to the concentration of the substrate and nucleophile. That means the order of the reaction is 2. Order is equal to 2. So that since the order is 2, so that the reaction is called bimolecular or SN2. If its order will be 1, then it is called SN1 reaction. Why it is order is 2? Because it comes depend upon the concentration of the substrate and concentration of the nucleophile. Right. So these are the basically the outline of the nucleophilic substitution bimolecular. You can note down from here. These are the basically the SN2 mechanism, and in next video I will discuss the SN1 mechanism. So thank you guys for watching my video. If you like this video, please subscribe my channel, like and share with your friends.